Hello, welcome to my talk. So I will talk about the TEMPEST threat. So first of all, a few words about me. I work at ANSSI in France. It's the National Cybersecurity Agency. I'm in a wireless security lab, which deals with everything which is wireless, so Wi-Fi, Bluetooth, physical layer, embedded system, signal processing, and more particularly electromagnetic security. I have a PhD in electronics, and I'm an electromagnetic security expert, and I'm the TEMPEST team leader at ANSSI. So what is TEMPEST? If you have a look on Google, it gives some results. So it can be planes, boats, singers, many things. But fortunately, I won't speak about all of this. I will speak about electromagnetic emanations. So we'll see the origins, the impacts on security, and how to protect sensitive data. So first of all, EMC is very well known from everyone. The goal is to give a set of rules to assure that several electronic equipments can work together. To achieve this, there are two fundamental principles. First is called emissivity. Any electronic cards, when it works, it generates parasite around it. They can't be cancelled, they are always here, but just they are more or less powerful depending on the cards. The rule is that this parasite need to be low to avoid perturbations on other equipments. If it's not the case, in France, we have an organism which is ANFR. It's the French agency for the frequencies, and it gives many examples. So I just chose one on a wireless headset, which did not respect the EMC rules, and it disturbs the 4G communications 10 kilometers around. Second principle is the susceptibility of an equipment. It's the ability to work with other equipments around that generates electromagnetic emanations. So this level should be high to avoid disruptions. If it's not the case, I took just one example. It's the fishbowl operation during the 60s. Americans did nuclear explosions at high altitude, at 400 kilometers altitude, and there was an impact in Hawaii, which was 1,445 kilometers away. So EMC rules need to be respected, and since 2014 in EU, every equipment with electronic cards need to respect EMC rules. So now we're going to see the link between EMC, IT security, and TEMPEST. If a card, an electronic card generates parasites, and if you can collect these parasites, you can get access to the information. So that's a problem. For example, here, suppose that the first line A is sensitive data that is on a bus on a card, and we can collect traces B and C. If we have a look to B, each time we have a pulse, it corresponds to a transition from low to high in A. So from B, you can regenerate A, so it's compromising. If an attacker gets signal B, it's a problem. If we have a look to C, sometimes it corresponds to transition, sometimes it corresponds to nothing. So this one is not compromising. So all the objective of protection is to avoid the attacker to get access to B. If it access to C, it's not a problem. Now, if the link with susceptibility, so if the electronic board can't resist to electromagnetic emanations, you can imagine that if you send a strong wave or smart waves to this card, it will disrupt. So we can make a link between IT security and EMC. The link between emissivity and confidentiality is called TEMPEST. And the link between susceptibility, integrity, and availability is IEMI. It's intentional electromagnetic interferences. So in this talk, we will focus only on TEMPEST. Where does it come from? In an electronic board, you have many nonlinear components. So if you have a data signal, numerical digital signal, with a clock signal at the output, you have a mix of both. It's amplitude modulation. So this signal can be emitted. Now, where can we have the leakage? Let's suppose a laptop which is connected on the left to the power supply, on the right side to a network, and there is it at the top with metallic conductors that are not so far from the laptop. So first of all, we can get leakage on the power supply line. Also on all other lines connected to the laptop. Over the air, it's the most known. And if metallic conductors are not so far, these waves in the air can couple to the metallic conductors and go away. Actually, the most risky case is the video signal, because it's a repetitive signal, so you can make an average to improve the quality. And the leakage is amplified with the presence of badly shielded connectors, like in the bottom. So if you use only a shielded connector, the signal can't go out and you just can't get nothing. But if you use a glued connector, the waves can go out from the glue, and you can get the information and reconstruct the signal. Furthermore, with VGA signals, we just get the borders of the picture. So sometimes it was difficult to have an idea of the image. And now with digital video signals, we also get the contrast. So the quality is really better. So now let's see how to protect. First of all, if you protect only against electromagnetic emanations, it's a nonsense. You also need to protect against every other threats, like physical security, IT security, site and acoustics, for example. And the protection is, it can be seen as a balance between the protection given by the equipment and the protection given by the building. For the equipment, the protection can be made by a selection on the equipment, and on the building, the protection is linked to the materials that are used to make the building and the distance. The best protection, of course, is a Faraday cage or a shielded enclosure. Everything is done to isolate the inside world from the outside world. And typical attenuation is 100 dB between 10 mega and 1 giga for a classical cage. Of course, the door shall stay closed. If not, the protection is over. And the speech is not protected because the speech frequency is very low, so it's under 10 mega. And it's not efficient against communicating devices because the 1 gigahertz is too low and 100 dB it's not sufficient. Today, you have solutions. You can add acoustic protection to your shielded enclosure. And you can also raise the performance to, for example, 140 dB and 40 gigahertz. Today, it's a classical performance that can be reached really easily. Just an example, in the Vatican, they designed a Faraday cage to protect the papal election against the communication device during the discussions. But this is the Vatican, they have many money, and it's not the case for everyone, and sometimes you just can't use a Faraday cage. So what are the other solutions? Let's see the protection from equipment first. So when you have an equipment, you can make a measurement in it, and we call this TEMPEST evaluation, to give it a level. So level A, it's specifically designed equipments. It's like Faraday cage equipment. B are good, C are not so good, and D are prototypes. So here you have some example of level A equipments. The one on the left is not really recent, but it has the advantage to show all the filters on each line. In fact, each line that penetrates the computer, it is filtered. So each box is a filter. Yeah. And we have exactly the same for the other equipments on the right, but it's not visible. So these are level A equipments. Of course, as they are designed, specifically designed, they are more expensive than classical equipments. We can make evaluations. I said it before. So the goal is to you put your equipment inside the Faraday cage. You measure the parasite level at each frequency, and if it overcomes the limit, so you make an analysis to see if it's a compromising signal or just a clock signal. So here, just for information, the limit is not the real one because it's not a public information. So I just put a limit just to show something. In the building, we have the same process. So for each room, we can make measurement between the room and the limit of the control space, and we measure the attenuation. And after this, we have a classification of each room, and we know if we know the attenuation. So, for example, here it's red; it's not protected at all. Here it's well protected, and the blue is a sort of Faraday cage, so it's really well protected. And after, with this, the idea is to put the good equipment in the good place. So if you take a weak equipment in a weak room, so you have a possible leakage, you have no protection. If you put a good equipment in a good room, you have an additional cost that is not justified. You have a surprotection, in fact. And the good trade-off is a strong equipment in a weak room or a weak equipment in a strong room. So let's have I was saying one demo, but I have 3 demos, in fact. Take this, yes. So here, I have a monitor which is connected to a laptop, which is here. And between them, I just put a bad cable. So it's unshielded cable. So what I will do is trying to get the video signal that escapes from the unshielded cable from an antenna. So I just need 1 minute to set up. So here the advantage of this attack is that we don't need any physical access to the equipment. In general, when we go on site, we can make interceptions at several tens of meters. Okay, let's try. So in my interception chain, I have a very cheap antenna. It's 10 euros on Amazon. So it's a really cheap antenna. So the quality is not as good as we get when we go on site. But this is just for the demo to show you what we can do with a few euros. I took a spectrum analyzer, which get the signal from the antenna and sends to the computer. In the computer, I use TEMPEST SDR. It's a software which we can get in GitHub. So here I just configure that I want to get signal from BB60. And let's start. The interface is really, let's say, simple. Everything is automatic. So here you can set the resolution if you want. Here, most important, you can put the interception frequency. So it's the frequency at which you will have a look. Here, for example, at 455, we have a signal. If I change here, so here I have signal everywhere. Here, for example, at 235, we have no signal, we have no leakage. So we have a look, and let's go. Just search. You can see I'm not really have a specific direction with the antenna. Okay. So here we have a signal. So now we are going to make it synchronized. I think it's not my signal. Never mind. Okay. So I saw this during lunch. There is another computer which is very bad in the building. So let's try to get mine. This one. Yeah. Is it possible just to unplug it? Just, I will take it for the next demo after, if you don't mind. No, you need to unplug. It's the cable, yes. Well, let's try to get mine. I think it's not this one. It's my screen? Oh, okay. It's my screen. But I didn't have this before. Okay. The cable is very short. Let's see upper. It's the demo problem each time. Here we get it. Here it comes. Okay. So I said before, the quality is very low because it's a very, very cheap antenna. So this is the signal that escapes the cable. Okay. So now I just change the cable with a good one, just to show you the difference. I remove the bad cable. Let's verify. So here you can see we have nothing. We can check other frequencies. It's not our signal. Okay, we have lost the signal. So for the attacker, it's not possible. Let's say it's really hard now to get the information. But if it has access to the power supply, there is another leakage. So now we'll try to get the video signal that leaks in the power supply line. And for this, I use a current clamp, which gets the signal that is coming into the cable inside. So let's have a try. So I put it on the power line of the monitor. I connect it to the spectrum analyzer and to the computer. And now let's have a look. Just before, in radio frequency signals, high signals, they propagate in the air, high frequency signals, and low frequencies, they propagate in the metal conductors. So here I will go really down the frequency to see if I have something on the power supply. So here we can see something. Perhaps you can have better. Yeah. So let's try to synchronize. I think it's again my computer. This one is the good one. Yeah. Okay. No, in fact, what I changed is just to connect my power clamp to the spectrum analyzer, but that's a direct connection. I just use a small cable to protect the connector of the spectrum analyzer because it breaks often, but that's the only condition. Okay. So just a very small conclusion. In YouTube, you have many videos that shows a TEMPEST threat with interception over the air with the antenna. But you have nothing that says that there is a real danger on other leakage paths. So beware to the power supply because it's really a danger for your sensitive information. Thank you for your attention.
Okay, that was some impressive witchcraft, and I guess we have some questions.
Thanks, Emmanuel. Nice demos, presentation. How easy is to do in a multi-apartment building, like power supply, Tempest of the neighbors, Meaning, does the buildings, let's say, power transformators and things like that and smart meters affect this or filter out or make it better? I don't know.
So there are, it's a very good question. I have several answers. First, if you are at home, it's easy because you have no many equipments, electronics, so you can spy the computer of your neighbor if it's bad. In a building that is your own building, there are a lot of equipment, so the noise level is very high, so you can't get anything. But in a shared building, if you only control one level or half a level, here you need to protect yourself because the protection is not sufficient. So it's a problem. Our problem today is really the shared buildings.
Thanks. We've got another question.
Hi, Emmanuel. Great talk. Really interesting. I want to know more. And the first question that comes to mind is at what distance you can do that? Is it especially power leakage? Not so much cables, like video cable, but power leakage in terms of here you needed a power clamp. With the video cable, you needed an antenna. So in either case, at what distance you can do it with what's just available, like you bought something out of, not this equipment that's cheap, but in general, at what distance you could do that?
Let's say with the equipment that we use at work every day, let's split the conducting problem and the aerial problem. In conduction, if you don't have, let's say, power filters or well installed electric how do you say that, electric board with the disjunctors, if you don't have protection, you can go several hundreds of meters because it's made to propagate.
Several hundred?
Yeah.
So you can be standing on the street and sniffing the image on the monitor from the street standing next to the building?
In the power supply, yes, if you have no protection.
Okay.
In the air, let's say several tens of meters.
Thank you.
Well, I guess still standing on the street. We've got one question over there.
Yes. Yeah. Since if you're targeting a private company, they will tend to buy their monitors or whatever equipment in batches. Yeah. And then you will have like 10 of the same, like, screen. How easy is it to actually target one specific when you have like this? Because they will tend to irradiate in more or less the same way and at the same time.
Of course, if you have only one bad equipment in a building, it's really easier to get it. If you have several equipments, the difference is made on the synchronization. Your laptop is, or your monitor is 60 Hertz, but it's not really 60 Hertz. And the difference, can make, you choose the equipment you want. For example, here it's 59.93267607, and it's for this computer. If I change another computer, I will change the frequency.
Yeah, but so in your experience, there's enough variation in between, even if it's the same model, yeah, that you can like finally select, yeah, the center frequency, yeah, to pick one, yeah, specific. Okay.
Yeah. When you are in a room with 5 or 6 computers, you can get each one. But if you are outside of the building and you have, let's say 100 times the same equipment, it's really, really difficult. Except if only one is bad.
Okay, thank you. That was a great presentation.
Thanks.
All right, we've got a question here.
Does this mean that higher resolution and higher refreshing rate are more difficult to get?
Sorry?
And does it, I mean, your previous reply, does it mean that higher resolution of the monitor and faster refreshing rate is more difficult to get? Because there are monitors like 120 hertz.
Today, if personally I would hide my computer, I would take a computer at full HD definition, because almost every computer is at this resolution, so it's common. If one computer is in another resolution, it will be really easy to get it. In fact, because it gets out of the noise.
And the second question is about phones. How easy would be to have a direct attack, like a direct pointed antenna to check the phone when I'm typing a PIN code?
Yeah. Here you don't have the problem of the cable, of the bad cables. In a smartphone, everything is done to go quick and fast. Everything is really well done. And if you are more than 10 or 15 centimeters, it's really difficult to get something. You really need to get close access.
All right, we've got another question here. That's a pretty hot topic.
Here. What is the scope of Tempest? You covered video cables, power. You cover Ethernet, 50 hertz, those ranges as well. What is the full scope? What all can you cover?
Let's say that Tempest threat is the threat that is linked to the fact that the attacker can get information and reconstruct it. So it can be, we work on every signals that are generated. So it can be Ethernet, USB, video cables, and really a lot of things.
All right, we have another question from the same side.
Which video cables would you recommend for best shielding? So, and which video format? So, is DisplayPort also applicable, or is it more difficult to sniff DisplayPort, for example?
I didn't catch the end of the question.
Is DisplayPort better than HDMI and DVI?
Yes. So just on the selection of the cables, just a small word, because it's important for everyone. If you buy one cable in a supermarket, it's not an electronic component, so it doesn't have to respect EMC rules. So generally, it's not shielded. It's 99% not shielded. If you get a cable that is given with an electronic equipment, it has to respect EMC rules. So generally, it's shielded. So the recommendation is to get and to use the cables that are delivered with the equipment. For the video protocols, today in a DisplayPort, there is a scrambling of the signal before sending it on the cable. So if the attacker will get the scrambled signal and it can't do anything on it. So it's really good. In DVI and HDMI, you have no scrambling. It's a direct signal.
All right, another question from the middle.
So a previous questioner asked about the relationship between the frequency of the monitor, and you had answered in the context of resolution. So earlier in your presentation, you said video signals are easier because it's 60 per second and you can average it. So the previous person asked, like, what about 120 megahertz? 120 hertz. Is that better or worse in terms of, like, as the frequency goes up, does it make it easier to recover the signal or harder?
I have no link on this. On the evaluation we make at the labo, we don't have a link between, for example, 4-key equipments and their quality. And we have always good equipments and bad equipments. We don't have bad brands. Sometimes some Dells are good, some Dells are not good, some Lenovo are good, some others are not good. We have really no rules today.
So sorry, to make sure I understood, you said you have no data on the differences that the refresh rate actually makes. It's more just the equipment is good or bad intrinsically. Okay.
All All right. Thank you. Do we have any last question for today? No last question. That was fascinating piece of witchcraft. Thank you, Emmanuel, for the talk. Let's give a warm round of applause.